Welcome to the Dresden Switchyards presentation number 2. In this presentation, we will cover Objective 2. As always, let us take a 2-minute drill to validate we're ready for training. Please make sure that your cell phones have been turned off. Validate that you have the correct lesson plan. Today, you should be looking at DRE 262 Lima November 003. Please be attentive to this presentation. Take breaks as needed, and as always, provide feedback to the training staff. Should be noted that while this is Objective 2, it is recommended that you watch the video on Objective 4 before watching this particular video. Our objective for today is to discuss the circuit paths associated with the switchyards. Our discussion includes the major components, the normal, abnormal, and secondary flow paths, and the interrelationships with other systems as found on plant reference drawings. This particular system also requires the use of a drawing created by the student from memory. As in the previous video, we will start with the 345 kV switchyard. Please take out a blank piece of paper and follow along with the drawing as we do it with you in this computer module. We're going to start by looking at the 345 kV switchyard drawing. The first thing we want to do is draw our two connected boxes. Notice that the boxes are colored blue and red. If you remember back to Objective 1, we said that the 345 kV switchyard was a double ring bus configuration, and that we had a blue bus, which was the northernmost bus, and the red bus, which was the southernmost bus. If you've watched the video on Objective 4, you'll see what we're talking about when we talk about a red bus and a blue bus being the south and the north buses respectively. For our drawing, we're going to start with two connected boxes. Notice the black line that connects between the red bus and the blue bus. Our next step in drawing our picture is to add the input voltage or input sources for main power transformers 2 and 3, and to draw on the circuit breakers. Transformer 2 feeds the blue bus. You'll notice the black arrow at the top of your screen, labeled Transformer 2. Transformer 2 directly feeds into 345 kV bus 1. Transformer 3 feeds the red bus. You'll see that Transformer 3 is the black arrow on the south portion of the picture. Transformer 3 ties into the ring bus at 345 kV bus 10. You'll notice that we have rectangles with numbers in them. Those rectangles are the circuit breakers for our drawings. Our circuit breakers are labeled by which buses that they connect. So for example, the bus with the 1-2 in it is the 345 kV bus 1, 2 circuit breaker. In other words, this circuit breaker is what ties bus 1 to bus 2. If we look at the 8-15 circuit breaker in the red bus, that circuit breaker is 345 kV bus tie 8-15, or it's tying the circuit breaker, tying the buses, bus 8 to bus 15 through the circuit breaker. Now, you probably noticed that we go from bus 8 to bus 9 to bus 10 to bus 11 to bus 14, and then suddenly we're at 15. There is no reason why this is to occur. This is just a nomenclature issue that has occurred when we were designing the plant. Our next step is to tie in or draw in the bus disconnects and grounding disconnects. If you remember back to our Objective 1 discussion, that the switchyard's purpose is to provide equipment that will allow for isolation for maintenance. This is what the disconnect does. A disconnect is a physical device that will separate the buses from each other using a pole and a motor. And we'll look at those when we get to Objective 3. Each circuit breaker has a disconnect on each side. So in other words, if we again look at the 2-3 circuit breaker, 345 kV 2-3 circuit breaker has a disconnect on the bus 2 side as well as a disconnect on the bus 3 side. It's very important for us to understand the nomenclature. So for example, if we're looking at 345 kV bus tie 2-3 circuit breaker, the disconnect on the bus 2 side would be 345 kV bus tie 2-3 bus 2 disconnect. The disconnect on the bus 3 side would be 345 kV bus tie 2-3 circuit breaker bus 3 disconnect. The reason why we stress using proper nomenclature when talking about the switch yards is that an error in the switch yards could result in death. So it's very important to make sure that as an operator, you're operating the right pieces of equipment. Now you'll notice that there is a difference on our drawing between some of the circuit breakers and their disconnects. This disconnect, for example, is 345 kV bus 815 bus 15 disconnect. You'll notice it has a little line and a circle drawn off the disconnect. That symbol represents the fact that that disconnect is a motor-operated disconnect, whereas the disconnect over here on bus 1114 is a manually operated disconnect. It does not have a motor. The last part of our drawing is to add in the connections to the other switch yards as well as the lines that we feed. You'll notice, as we talked about previously, transformer 81 is on the blue bus and it feeds 138 kV switchyard bus 4, again illustrating the thumb rule of 5. The 1 in 81 plus the 4 equals 5. Down here, we have transformer 83, which is the feed to 138 kV bus 2. Again, 2 plus 3 equals 5. You'll notice that some of the disconnects on the lines are motor-operated disconnects, while most of the disconnects on the lines are manually operated disconnects. The line nomenclature also has some funny features to it. For example, if we take line 1221, the first two numbers stand for the generation station. Since Dresden Station is station 12, line 1221 originates at Dresden Station. Line 21 represents the station that it's going to. If you look at line 2311, for example, that comes from station 23, which was Collins Station, and is tied back into us. Let's move on to the 138 kV switchyard. If you remember back to Objective 1 video, we said that the 138 kV switchyard was different from the 345 kV switchyard in that it wasn't a ring bus. It's a straight line bus. Our straight line bus is broken up into 4 separate buses separated by disconnects. In this case, we have 138 kV bus tie 1-2 circuit breaker, 138 kV bus tie 2-3 circuit breaker, and 138 kV bus tie 3-4 circuit breaker. As we talked about earlier, 138 kV bus tie 2-3 circuit breaker is normally open, and that is what gives us some divisional separation or protection in the switchyard. You'll also notice that we have feeds coming in from transformer 81 going to bus 4, as well as transformer 83 going to bus number 2. This drawing also shows the step-down transformer, 138 kV voltage on the high side, stepping down to 34 kV, feeding 34 kV switchyard. As we talked about in Objective 1, you'll also note the reserve feed going to transformer 22. After we add all of our breakers and disconnects, we finally put in all of our lines. You'll notice that the 138 kV switchyard has 6 lines that go out to feed various substations. It's important to note that there are these ice melt disconnects between line 138 kV line 1205 and 138 kV line 0904. The ice melt disconnects can be closed to generate heat through I squared R losses, which helps maintain the lines free of any ice buildup. Another symbol that we didn't talk about with the 345 kV switchyard drawing was this grounding disconnect. We have the ability as part of our maintenance to ground the line using a grounding disconnect. And that's there for personal protection if the overhead line workers had to go to work on any of the lines. Last but not least is a 34 kV switchyard. This one's a pretty straightforward drawing. From the 138 kV bus, in this case 138 kV bus 4, our voltage is generated through a step-down transformer, transformer 10, and feeds our three lines, 34 kV line 7280, 34 kV line 1263, and 34 kV line 1266. If you remember back to Objective 1, we pointed out that there are various loads that are powered off of these lines, and they're listed here. Examples would be the flow regulating station, our cooling towers or lift station, as well as some of the non-power block buildings, for example, the training building. Our objective in this particular module was to discuss the circuit paths associated with the switchyards. Our discussion includes major components, normal, abnormal, and secondary flow paths, and interrelationships with other systems as found on plant reference drawings. Please be aware that for this system, you will be required to draw a drawing of the switchyards from memory. It is recommended now that you watch the presentation covering Objective 3 next.